What is a mechanical seal? Simply stated, a mechanical seal prevents the mass leakage of a liquid or gas from between a rotating shaft and a stationary housing. In this example, we will look at a mechanical seal in a pump. The driven rotating shaft passes through an aperture in the pump housing. On the end, we can see the spinning impeller, which is attached to the rotating shaft. We can also see liquid escaping between the rotating shaft and the aperture. We are now going to build a mechanical seal to control this leakage and allow the shaft to rotate the impeller freely. We begin with the housing for the mechanical seal, which is fixed to the wall of the pump. The mechanical seal itself is made up of 4 key components. The first is called the mating ring or seat. The mating ring is fixed to the inside casing of the pump housing. In this example, the mating ring is static. The second component is called the primary ring, or face. In this example, the primary ring is attached to the rotating shaft. The third component is the spring assembly. In this example, the spring assembly is also attached to the rotating shaft. The springs act on the primary ring to maintain a constant gap between the 2 seal faces, allowing for thermal expansion and minor axial shaft movement. The fourth component is the secondary seal arrangement. One seal sits within the rotating primary ring assembly, or face assembly, and prevents leakage along the rotating shaft. The second sits within the static mating ring, or seat, and prevents leakage around the mating ring. The seal is now complete, and the leakage has been contained. The space between the mating ring and the primary ring is the sealing gap. This sealing gap is just a few microns thick, 1/30th the width of a human hair, and keeps leakage within acceptable levels for that application. For the seal to function, the 2 seal faces need a process fluid for cooling and lubrication. In a wet mechanical seal, the 2 seal faces are contacting and lubricated by a very thin fluid film. This fluid could be the process fluid itself, in this case the water in the water pump. Depending on the application, the seal may require a seal support system to ensure lubrication. A seal support system controls the flow of a separation fluid to consistently separate and lubricate the 2 seal faces. In this example, the separation fluid is introduced through a flush system onto the seal. The separation fluid then circulates through the seal, providing lubrication and cooling before exiting through the seal housing into the pump. The sealing process reaction may also create a build-up of solids on the atmospheric side that need to be removed to ensure the seal remains contaminant-free and the seal faces don't become damaged. In this example, a quench system circulates a draining fluid through the seal housing, flushing any solids out into a collection trap. The seal is now functioning in 3 ways. Firstly, the shaft and impeller can spin at high speed because the seal faces are separated by a thin fluid film. Secondly, the thin gap between the 2 seal faces, just a few microns thick, controls leakage. Thirdly, the seal is being supplied with separation fluid by the seal support system, and the quench is removing any build-up. This completes the working principle of a mechanical seal.